First, the copper here has this 2 plus. We're going to put a 0 on the aluminum there. This aluminum has a 3 plus, and this copper gets a 0. These two are both neutral elements in their natural state. Just so y'all are aware, the AQ, the S, and so on, these are just states. They are not participants in this chemical reaction. They just tell you that, for example, this copper 2 plus is dissolved, and this version of aluminum just happens to be a solid. Now that we've done that, we're going to use tie lines to connect the things that are changing. So copper with copper, aluminum with aluminum, and then I'm going to label these based on how they're changing. The copper is going from 2 plus to 0. Remember that a positive means you're missing electrons. So copper has gone from missing 2 electrons to not missing electrons, so he gained electrons. Remember that reduction is the gain in electrons, so copper 2 plus was reduced. The aluminum here is the thing that was oxidized. And we know that because it went from having electrons, or having an equal number of electrons to protons, to now missing 3 electrons, which is why he's a 3 plus. Now, we're going to split the reaction up into 2 halves. So one half will be the reduction. That'll be copper 2 plus becoming copper solid. The second half will be the aluminum solid becoming aluminum 3 plus dissolved. Then we're going to balance these 2 half reactions. Now remember, always check for mass. Now, copper in, copper out, aluminum in, aluminum out. There's nothing to do for mass here, but there are instances where you'll need to balance it by mass by putting in coefficients. But really what we need to do is we need to balance these things by charges. Now remember, we do that by adding electrons, which will make one of the sides more negative. We do that to whichever side is already more positive. Since this side is too positive and this side has no charge, I'm going to add 2 electrons over here to balance the charges, and I'm going to add 3 electrons over here to balance those charges. And then I need to multiply both of these equations so that the number of electrons going in and going out matches. I've got 2 electrons going in, I've got 3 electrons going out. I'm going to have to bring the number of electrons up to 6 in order to get these two to match, because I can't make a 2 into a 3, and I can't make a 3 into a 2. So least common multiple, 6. That means multiplying this equation by 3 and that equation by 2. And then I'm going to combine everything back together. So all the reactants on one side, all the products on one side. But I'm going to have to multiply things to make that work. So 6 electrons and 3 number 2 pluses. They still get the AQ. And 2 of the aluminum solids yield, coming over here, 3 of the copper solids and 2 of the Al3 plus, and of course 6 electrons. And the final thing is eliminate those electrons. If you've done this right, the number of electrons should cancel out from the reactants and products, and what's left for starting with here and going across is your final answer. There is your balanced redox equation. If you've done this right, the charges should still balance. So you notice how I've got 3 2 pluses? Well, that's 6 plus. Go over here, 2 times 3, 6 plus, 3 coppers, 2 aluminums, 2 aluminums. Just a quick, easy way to check your work